The following presentation is to Clark Construction Group in regards to the engineering interdisciplinary complex at San Diego State University. This project is presented by Cora Butler, Lakshay Kathuri, and Samantha Teague. The following presentation is a response to the IRL open issues. In a response to the open issues in the issue resolution log and the cost concerns, our team has been diligently working to correct and improve these issues. Your concern about our team performance and unresolved issues is an extreme importance to us. It is our goal to provide the highest level of quality service to our project team, clients, and professional colleagues. Through our commitment, we have found ways to address all concerns that have not previously been shown attention to in the IRL. As you know, our project team shares purpose, values, culture of the project being conveyed. We are dedicated to working together as partners, communicating and contributing to the ultimate goal of providing a built environment that promotes health, safety, and welfare of all who use it. The design scope is as follows. The integrated team will address all issues in the IRL in the manner that Clark Construction Group has specified by presenting the following deliverables: our mission statement, team charter, scheduling, bringing all the project back in line, a budget showing our project back to its allowable cost, various design options, the owner requested steel and glass front entry, a site plan for traffic, our recommendation of steel versus concrete, our proposed plan for the fire marshal, and a description of the 5-minute onboarding presentation. Our mission statement: to provide the highest level of quality service through dedicating us to be honest, fair, and hardworking individuals. Our commitment is to our clients, employees, and professionals we have the pleasure of working with. Our mission is to listen to our clients and deliver a product that captures their vision. It is our goal to provide excellent service and be empathetic towards all comments, questions, and concerns. Our team charter will cover what is stated by the owner in their statement value and conditions that they'd like satisfied. The purpose of the document will be to document the following topics: project need, expected outcomes, authority, key external processes, key stakeholders, decision process, meeting management, deliverables, and charter expiration. At the end of the document, there will be enough spaces for all IPD team members operating under an integrated form of agreement to sign, agreeing to what they've seen stated in the document.
So to keep the project cost under the target estimate, we compared our key documents, summary estimate, and owner-defined statement of value to find areas for improvement. Collectively, we noted areas where we could be able to reduce these costs. So since concrete budget is almost over 25% target estimate, we are suggesting to use precast concrete to reduce this cost. Some websites have suggested that a cost reduction of around 23% can be seen on average when choosing to go from a on-site to a precast concrete. Since finishes are also over 15% target estimate and they have not been specified yet, we propose to use cheaper finishes wherever we can and maybe keep exposed surfaces wherever possible. Also, electrical and mechanical budgets are together over budget by 1.2 million. We are proposing to reduce these costs for electrical by reducing the circuit length through efficient planning in the value engineering stage. Also, off-site fabrication can also reduce on-site labor cost for the electrical as well. In terms of mechanical, the current design hosts 3 elevators and the program has only called for 2. So we are suggesting to cut down on one of these elevators to reduce the mechanical cost. We also notice that stair force position causes it to not go all the way to the roof, requiring a 5th staircase. So for this, we recommend to eliminate this waste by changing its orientation so a new stair tower isn't required. The design also uses several full-height glass walls that are expensive to build. We're suggesting to go with 3 feet visibility panels in wall instead. To keep the schedule on track, Efficient relationship between activities could be formed and negative lag could be administered in activities wherever possible. Since the project is behind schedule and over budget, spending more time in the pre-construction phase and in value engineering to align activities will help. A lot of construction activities can be done in parallel and a lot of construction time related to that can be saved. Because of the collaborative work, most permitting and approval times are considered to be pre-planned and are eliminated at each stage. Efficient planning can help in planning all procurement activities to be started on time to eliminate all lags because of it. So because of all this, the new finish date is now 18th July of 2018, which is earlier than the suggested deadline.
Our construction management plan will explore our different design options as well as other open issues covered in the IRL.
Co-location in construction management and architecture refers to a common office hub where key team members work together to achieve aligned and optimized project goals using BIM, lean principles, and IPD processes by leveraging teamwork and synergy. We created a flexible seating arrangement that could be determined communally, depending on who needed close proximity to collaborate. We accommodate groups of varying size and played with the concept of formal and informal spaces as a way to balance people who are more comfortable in traditional environments, while informal spaces are designed to take more fluctuations and be transformable. We foster a collaborative culture through using various walls as pin-up space or whiteboard space. We keep everyone on track with a wall-size schedule and informal morning meetings. Our first design option study was to reduce the full height glass walls to a regular stud wall with a 3-foot visibility panel. Functionally, this achieves the same safety objective of being able to see into the space and be aware of the ongoings of the lab. Aesthetically, is a detraction because you're not able to see the complete space. However, it still offers just enough of a view to pique someone's interest and draw them to the space. For this exercise, we calculated out the linear feet of the full glass walls, which is about 840 feet throughout the entire building. While we believe that the resolution lies with having full glass walls at key parts such as the first floor, cafe, and key walls in public spaces such as the meeting rooms, we have shown a comparison of the full glass versus the visibility panel wall for all of the walls. Our second design option was to look at the main entry, which we later evaluated again by looking at the modern glass entry. Originally, we picked this space to do a design option because unlike the north and south building, it doesn't hold highly technical programs such as labs. We felt that the current design was overbuilt for what it had to be functionally, and it was the greatest area for slashing the price of the overall building. To calculate the difference between the options, we used the vertical height between the floors to calculate the area of the wall space. We multiplied 1 by $25 for the cost per square foot for storefront glazing. And then we compared it to the other design option by multiplying $5 for the area of the stud wall plus the area of the vision panel, again by that $25 for the storefront glazing. The difference between the options was around $185,000. We are going to later discuss the design strategy for areas to use this more expensive option and areas where the design will make a bigger impact. We later revisited this when the owner requested we look at a modern steel and glass entry. This concept is an open colonnade repeated on both floors. The storefront and skylights allow plenty of natural light into the space and offers great views of the courtyard. This modern entry breaks away from the Mission Revival style, but keeps the building's internal rhythm and tries to emulate the color of the terracotta tiles with its red storefront framing. Our team had worries about its greenhouse-like effect of the California climate and it gobbling up more of our mechanical and electrical engineering budget. We highly recommend not going with this option as it would be an eyesore, energy vampire, and have negative impacts on the budget.
Comparing the two design options in terms of cost, the cost of material is much cheaper for the colonnaded design option, that is the option 1. This is because the first option will save money in terms of wall area footage and material cost since there is an open archway and colonnaded on the first floor. Glass facade for the option 2 on the other hand will be costlier in terms of material cost as well as the wall area covered. The glass roofing is also another high cost item that makes it the costliest option among the three. The structural cost of the steel and glass option however will be cheaper in terms of material due to the cheaper cost of the structural steel. When compared to the original design, the first option is the preferred design to save material cost. Constructability varies for both of these options provided. The first option will require skilled labor if built on site and will be costlier and slower compared to the installation of glass wall. Contrarily, the structural construction time will be lower in case of the concrete option, saving time and money when compared to the steel structure.
The site plan was developed as a response to an open issue in the IRL stating there is a need for a site utilization plan that can be shared with campus or operations showing truck access, parking, equipment plan, hoisting plan, dust and sound mitigation, rerouting of student traffic, security, utilities, and temporary facilities. The document to the right of the screen will show you the proposed site plan.
We have decided to suggest concrete in comparison to steel, considering some of the criteria such as strength, safety, cost, and environmental impact. Strength-wise, a reinforced concrete structure has relatively high compressive strength and gets tensile strength as well due to the reinforced bars. Safety-wise, since it's an educational building, occupant safety is always a priority, and concrete's natural fire-resistant property and its ability to sustain high temperature without losing its structural integrity makes it a great choice for a safe fire-resistant building. In terms of cost, when compared to steel, concrete structures can be costlier in terms of the material cost, but since it can be sometimes built twice as fast, a lot of money can be saved in terms of a shorter schedule. For environmental impact, since the project aims to go for material and resource credit in LEED certification, which requires them to use a minimum of 50% of recycled demolished debris, and since the demolished building is also made of concrete, it makes a lot of sense to build the newer building in concrete as well.
The following response is a response to the open issue on the IRL regarding the fire marshal expressing concern about not having the capacity to review our project until January 2018. We have created a phased plan in order to allow for the fire marshal to review smaller components over a greater period of time in order to complete the project on schedule. The fire marshal reviews cover an array of drawings, specifications, and schedules. We elected to break up the information into phases based on how granular the information is. Our strategy behind a deductive method was the fire marshal would be able to review more specific information concurrently with how the design was being refined, thus saving time and speeding up the schedule. For example, we found very explicit and precise requirements for the lab in the building that would be pointless to cover during schematic design when layouts were fluctuating. While less items are covered in later phases, these issues will be resolved greater in detail. The phases are as follows. Phase 1. Identify occupancy class and compliance with special occupancy requirements. Identify type of construction. Provide site plan with hydrants, property lines, and setback indicators. Provide floor heights and areas for each story of the building and demonstrate code compliance. Provide a hydrant calculation. Provide design numbers for fire hydrant construction. Identify compliance with egress issues. Demonstrate accessibility compliance. Classify each space in the building with loads and calculations. Phase 2 will have provide details for fire-rated construction, identify identical use areas with calculations, provide deferred submittals if necessary, such as fire sprinklers, fire alarms, standpipe systems, elevators, etc. Phase 3 will consist of providing door lighting, glazing, and interior finish schedules, providing valid California State Fire Marshal listings for all fire-rated construction elements with expiration dates, and demonstrating compliance with interior environment requirements.
We participate in an onboarding because it provides a way for team members to reach common levels of project understanding and learn together. Onboarding ensures that teams' cultural, behavioral, and procedural environments are not disrupted by properly preparing new team members. Our presentation is a brief snapshot of our expectations for the project, where we currently are, and how we expect to move forward. We keep it brief because we believe in learning by action, such as icebreakers, tours through the office, sitting in on team meetings, and team building exercises.